Okay, a firm increases its revenues by 10% and then increases its costs by 8%. And we need to figure out what the percent increase is if the profits are defined as revenues minus costs. So P equals R minus C. P equals profit, R equals revenue, C equals costs. And then we can also kind of figure that we'll call X this percent increase, because we're going to have to set up equations for it. Why did I just write increase? Oh, no. Increase in profit. It's hard to talk and write at the same time. Okay. So again, in order to solve for this, we're probably going to need some more numbers, right? Because we have multiple variables. We do know initially, though, we can even set up kind of an initial equation. So we know that 1.1 times the revenue minus 1.08 times the costs is going to equal whatever the initial profit was times 1 plus the increase, that percent increase that we have. So if we can get some more of these variables figured out, we might be able to solve for this one. Statement 1 tells us that the firm's initial profit is $200,000. So we have so we have a couple equations. We know that the profit, which is 200,000, is equal to R minus C. That's from the original statement. We also can fill in one of the blanks here. So we know that the 10% increase in the revenue minus the 8% increase in the costs equals 200,000 times 1 plus whatever that increase is. The 1 plus is it's 100% of the 200,000 plus the additional X percent that it went up. However, this is still 3 variables, R, C, and X, and only 2 equations, 2 distinct linear equations, so we aren't going to be able to solve from that. So it's insufficient. We cross off A and D. Statement 2 tells us that the firm's initial revenues are 1.5 times its initial costs. This is helpful. So we have the equation P equals R minus C, as always, there's 1, which we can then transform into what the revenues are 1.5 times the costs. So 1.5 times the costs as revenues minus the real costs, which are just costs, equal the profit. And so we end up with 0.5C equals P, which is handy. We can then also convert this same ratio here over into our big equation over here. It gets rid of one of our variables. So we can say then 1.1 times 1.5 times the costs minus 1.08 times the costs equals this thing. And so, 1.65 times the cost minus 1.08 times the costs equals that thing, which I'm just going to leave there. So we get 0.57C equals that thing, the increase in profit. But then we also still have this thing over here that we can put in down here, which is given in terms of profit. So now we've gotten rid of our final remaining variable. So we get 0.57C equals 1 plus X times 0.5C. And we can end up with, as soon as you realize you have a real answer, you can stop. But we get 1 plus X equals 0.57 over 0.5. Whatever that ends up being, whatever fraction that is greater than 1, we can solve for x. Again, I don't want to do it, we just have to know that we could. So statement 2 on its own is actually sufficient to answer the question because of the way it allows us to eliminate other variables. Statement 2,